Right this moment, billions of subatomic particles are racing towards Earth at the speed of light and smashing to bits upon impact with our atmosphere. With each explosion, a tiny black hole is born. If it survives, it can grow powerful enough to prevent anything, including light, from escaping. But it doesn't. Instead, it dies in a few microseconds. What are black holes made of, and how do they work? The answers may be surprisingly close at hand. A black hole is one bizarre space object. Probably the best way to describe it is that it's defined by the absence of everything except gravitational force. The birth of a black hole begins the instant a star dies. During its life, a star burns furiously, and while it burns, it balances the gravitational forces that want to collapse it and explosive forces that want to blow it up. But as its nuclear fuel runs out, the star cools. Gravity takes over as the dominant force and begins to contract. Its atoms compress. It becomes very compact and very heavy. This kind of star, at the end of its life, is called a white dwarf. It may be the same size as Earth, but its mass is more like the Sun's. Originally, we thought that all stars ended their lives as white dwarfs. But scientists realized that if a dying star is at least 1.4 times the mass of the Sun, it would instead explode in a supernova, releasing much of its mass. The remaining core is now too small to resist the pressure of gravity. It collapses and shrinks infinitely, becoming a purely gravitational force. This is what we now call a black hole. If you could actually see a black hole, it would look like a bright, high-speed spinning disk. This surrounding bright light makes the invisible black hole appear to take the form of a black ball, called a black hole shadow. A border develops, separating the black hole from the space around it. Once this border has been crossed, nothing can escape its gravitational pull. This point of no return is known as the event horizon. The gravitational field surrounding black holes is actually quite small. If our own sun could become a black hole, then objects would have to come within roughly 6 miles of its center before they'd begin spiraling in. If you fall into a black hole, you are guaranteed to hit the center, which is called the singularity. At that point, you would be crushed into a ball of almost infinite density. So, when any light or matter crosses the event horizon, it gets pulled into that singularity and trapped, adding to the black hole's mass. And as far as we know, it will be stuck there forever. So how do you confirm what you can't see? One way is to start looking for things you can see nearby, acting peculiar. Scientists often start their search for black holes by looking for clusters of frantically orbiting stars. The gravitational pull of a black hole is so powerful that stars zoom through their orbits around it at fantastic speeds. This method has helped scientists determine that nearly every galaxy contains a black hole at its center. Another way to identify a black hole is to catch one gobbling up stars or gases. As gases are sucked into a black hole, they first flatten into a disk. Although black holes have a reputation as mighty vacuum cleaners, they can also act like giant leaf blowers. As the gases swirl around the disk, friction causes them to superheat and to produce intense radio waves. If these radio waves can be detected, they can indicate the presence of a black hole. The first stars to form in the universe were massive compared with those that came later. These monster stars would have burned out fast and produced black holes at least 100 times the mass of the Sun. But that's puny compared to the supermassive black holes we're finding today. Astronomers have known for more than a decade that at the core of almost all large galaxies, there is a supermassive black hole. The giant one discovered in the middle of the galaxy that contains our solar system, the Milky Way, is equivalent to 4 million suns. Supermassive black holes may start with the death of a star, but they can grow to 1 billion times their original size. How is this possible? One theory goes like this. At the end of their lives, stars explode, forming small black holes. These small black holes, called seed black holes, become supermassive by gulping down a huge smorgasbord of gases and stars, equivalent to hundreds of millions of our suns. Another theory holds that after stars die, explode, and form seed black holes, hundreds of millions of them may cluster together, merging into one supermassive black hole. Events of this scale take billions of years. We think that supermassive black holes were already in place when the universe was very young. In 2011, astronomers detected a hole that existed 13 billion years ago, only about 800 million years after the Big Bang. Roaming outside Earth's atmosphere, the Hubble Space Telescope can see space objects with incredible clarity, and what Hubble is finding is nothing short of astounding. Near the supermassive black hole at the center of our own galaxy, the Milky Way, it turns out there are many baby stars. New stars seem to be emerging from the gases that originally accumulated around the black hole. But in a science with more unknowns than knowns, one new discovery can change all previous notions about how the cosmos works. Recently, Professor Stephen Hawking shocked physicists by saying there are no black holes. He says that the idea of an event horizon from which light cannot escape is flawed. Instead, it's more of a gray hole. Hawking argues that light rays attempting to rush away from the black hole's core are captured as if they're stuck on a treadmill. And since a fundamental law of quantum physics states that no information can ever completely disappear from the universe, he believes the rays slowly shrink by spewing out radiation. As a result, the notorious black hole may not be quite as dark as we once thought. This new claim could ultimately refute the entire Big Bang theory, sending physicists back to the drawing board and relegating the concept of black holes to the realm of science fiction.